Hey, good. Here's another lesson for our group today. Geometric concepts, part three is what I'm calling this one because we've been talking about different geometric concepts. So here we go. All right. So problem of the day. This is from our segment bisectors. So what do we know? AM is 4x plus 100. All right. So that's what from here to here, right? MB is 10x plus 44. So that's from here to there. That's the length. It's just calling it an expression 10x minus 44, excuse me. So find AB, which actually it's the measure of AB. So once it's defined from here all the way to here. So draw these things out, guys. What's it want me to find? I'm trying to find the length of AB. What do I need to know? Well, I need to know X, because once I know X on either one of these, I can just plug in and I mean, that's going to give me the length of half of the length, so that I can just double from there. So if I knew what X was, I'm good, and then I can figure it out. So let's do it. So let's get my eraser up so I'm not all the way on that craziness there. All right. So that's 4x plus 40. We substitute. So sorry, can't talk, but you can see what I did. We substitute 4x plus 100 in for AM, for measurement of AM, and then 10x minus 44 for the length or measure of MB. And then we solve for X. Come on. Boom. Oh, I did something to the right side this time. I did 4x minus 4x to both sides and then add 44 to both sides. Only difference is 6x is on the right side. It's not any different divided by 6. So, then that equals to 24, which is Kobe Bryant. Yes, anytime I get 24 involved, Kobe is coming in. So, man, gonna miss seeing him. So, good man, good father. All right, so we are also trying to find what? AB. So all we got to do is plug in 24 where? Where are we plugging in 24? 24 is going in right here, right? So 4 times 24, which is what we're showing right here. Right there. And then we plug it in and we get the result. And boom. And then that's it. All right, so here's our objective. Students will classify and name angles. All right. The students will solve problems using the angle addition postulate and angle bisector. So classifying angles just means what kind of angles are they? That kind of thing. What kind of? So an angle formed by two rays or segments with a common endpoint is called a vertex, and you can see that drawing there. And I'll move my video recording over so you should be able to see it. All right, so common endpoint, vertex is the common endpoint. There it is, right there. That vertex has a common endpoint. A lot of vocabulary here. Naming an angle. So a little segment there, this little thing here. You just want to make sure we know this right here. That little thing is called means just angle A. So we just say angle A. All right. Now, more commonly, we call it by the 3 points, where we call it angle BAC, because it starts with B here. So it starts with B, and you go B, A, and then you go C, right? So angle BAC is one way to say it, or you can call it angle CAB. But the key thing is A has to be the vertex. You could call it angle A in this situation, but if you had a line that extended out farther and you had another point called D or something like that, then if you say angle A, just said angle A, you would have no idea what you're talking about. You're talking about this angle here, or you're talking about this. So that's why you have to use 3 letters sometimes. Angle BAC or angle CAB. All right. So, but if it's just a drawing where there isn't any other pictures involved, then you could call that angle A, and everybody knows what you're talking about. All right. That little disclaimer. Interior of an angle is the value of all the points inside. So that green section there. So let's move on. And then the exterior is anything on the outside. So you have point Z that is considered on the ray. So it's not inside or outside. or interior or exterior, then you do have a point, what was the point Y on the exterior there? All right, exterior of an angle, here we go. Again, it's on the outside. So Z is on the outside or the exterior, X is on the inside or the interior, all right? And QP is a side, so that length QP is a side. So from Q, this point, all the way down to P is that, and then QR as well. All right, so just kind of look at the drawing there. All right, they are called sides. And Q is the vertex. QP, ray QP, and ray QR are sides. There we go. So sides, just kind of illustrating it so you see it. All right. The measure of an angle is so the degree of an angle is use it to measure is based off the rotation of a circle using a protractor. So you kind of see you have that little segment. You rotate that angle, and if you look at it, let's look at my yellow here. So if you're measuring the rotation on the inside, there's the 0 here, right? And it rotates all the way to 40, right? If you notice these numbers on the outside, that's starting with a 0 on this side in case you were to measure it from the other side. You had an angle coming from over here or something. So just depends on which one you're going to use. Of course, these little ticks are a degree, all right? They're a little tiny degree, so 1 degree, 2 degree, just rotating. So, all right, so if you can also see over here to the side what a degree kind of looks like, it's 1/360th. So it takes 360 of those to go all the way around the circle, all right? So that's the idea there. All right, so the circle rotates 360 degrees. All right, and that's what the protractor is, half circle. So an acute angle is an angle that measures greater than 0 degrees, but less than 90. So 90 degrees angle, it could be 89.99999, and then it could be 0.000001, that kind of a thing. Anywhere between 0 and 90. So that is an example of acute angle. It's less than 90 degrees. All right, if it's exactly 90 degrees, then it's a right triangle. You see that? And then if it's bigger than 90 degrees, it's an obtuse. You see that? So obtuse, you see the 120 degrees is an example of bigger than 90, all right? But not 180, all right? 180, we have special names for those. So right angle is its own special case. It's not acute or obtuse. And then another one, a straight angle isn't a special example. It's basically exactly 180 degrees. So it's basically a line or a line segment. And you can see the rotation there. So basically, it just means you have a point on the line that's kind of like my center of my circle there when I'm measuring the angle, and I go to radius out, the equal radius, and just draw the arc all the way around 180 degrees. So that's why it's 180 degrees. So something a little to think about, because you're going to see this a million times in class. If I were to draw any kind of angle here, the sum of those two small angles now would be 180, because you'd have two smaller angles that both add up to 180. You can see because they're both because they're right on that line. So these are called linear pairs. I'm giving you a little head start because you actually will see this term later. All right, so congruent angles are angles that are equal in measure or have the same measure. And so if you look down here, you have different examples. So you got two intersecting lines, 134 degrees, that's 134. And again, we just kind of talked about that makes these 46, right? Because these two angles are on the same line. You got that from here to here, that half circle, so that adds up to 180. But if you look opposite, those are congruent. You kind of see every one of these have vertical angle pairs. They're all another word for vertical angles are congruent angles. I'm sorry, they are congruent angles, or opposite angles, excuse me. Vertical angles are sometimes called opposite angles, but vertical angles is what they are called. I'm jumping the gun on that. Angle bisector, just letting you know what they're called. All right, angle bisector is a ray or a segment that cuts an angle into two smaller angles that are equal in size. So little arcs with a tick mark usually means that they are congruent. Okay. Sometimes you don't see the tick mark. You'll see like something. You'll just see the arc, but in this case, it's done with a tick mark. I personally like the tick marks. Books sometimes don't. Sometimes they'll do two little arcs. Sometimes they'll do two. Sometimes what you'll do is you won't see the tick mark, and you'll see something like two markings, like maybe like two of those, and then maybe you have another marking over there or whatever. So, but don't worry about that. Right now, it says they're equal to each other. So that means those ABD and the other angle DBC, I think, are congruent. All right. Recap: acute, right, obtuse, and straight are your classifications. Angle addition postulate, so 60 plus 40 is 100 there. All right. So now we've got, look at that drawing there. All right. So you got 5x plus 10 is ABD, 2x minus 5 is DBC. And we kind of hinted at there, you go 180. Okay. So that's angle addition. And then didn't have to tell you it's 180 because on a straight line, if you draw that arc around, it's 180 degrees with a protractor. All right. So now we can just solve for x. And x will give us what we need to find the measurements. So now when you plug in that same drawing, you plug in 5 for x, you get 135 degrees for AB. And the other angle you can do as well. Sorry, I didn't show you that part. This is an angle bisector. So given RQ is an angle bisector, find the value of x. So if it's an angle bisector, we know that excuse me. Here we go. We know that PQR or PRQ, this angle, sorry I didn't draw very good, and RSRQ or QRS, either way, you can say either way, are equal to each other. All right. So then it gave us what they are, x plus 40 and 3x minus 20. They gave us what they are, so we set those equal. All right. Now we just solve. Minus 40, negative 2x equal negative 60, x is 30. So x is 30, you plug it in, 3x 3 times 30 plus 4 is 70. So 70 degrees for PRS, and because it's an angle bisector, I can already say that QRS is going to be 70 as well. And altogether, it's 140. Sorry, just to pause there. And there is our assignment. There's a quiz. And if you're substituting, just pause when needed. All right.